Hello, welcome back to Computer Science 4303. This is kind of a bonus tutorial lecture that I decided to do on the subject of Visual Studio Code and C++, and being able to use those for the assignments. One of the things that I struggle with a bit pedagogically for this course is using C++ is of course possible on Mac, Linux, or Windows, but it's a little bit annoying because we use Visual Studio for, not Visual Studio Code, but Visual Studio for the assignments in the course, and you get nice Visual Studio project files that you can just double click and run, and everything works perfectly. But people using Mac and people using Linux don't have that same sort of really nice streamlined experience. And so what I wanted to do today is just go over, for people who are using Mac, people who are using Linux, and for Windows, you can use Windows as well for any of this. I'm going to go over a sort of a tutorial to how to get a really nice C++ development environment set up using VS Code. Okay, so just again, a quick note about the terminology here. VS Code, I'm going to be saying VS Code, that's Visual Studio Code. It's sort of this lightweight text editor IDE, whereas Visual Studio is the Windows very large project thing that I talked about in the Assignment 1 lecture. So this is all talking about VS Code and how you can use VS Code to set up a really nice development environment for this course. All right, so here I'm running in a Linux virtual machine, and I apologize up front because sometimes when I'm doing this, my mouse gets a little wonky. So if you see my mouse disappearing or looking like it's lagging, I'm running a virtual machine inside Windows, and I've got the streaming software running, so it's all a little bit intense, but I hope it works out pretty well. So here, I'm just going to show you, if you go to code.visualstudio.com, that is the website for VS Code. And what we're going to do is we're just going to click here and download the Debian or the RPM for your Linux install. So I should say at first, sorry, so I can have nice little chapters at the bottom. What I'm going to do is I'm first going to show you how to set up and use this for Linux. And it should be very, very similar under Mac OS X. I cannot run a Mac OS X virtual machine legally here, so I don't have access to that. So people on Mac, you can pretty much follow these instructions because you have a nice little terminal that you can run and install things. And then what I'm going to do at the end is I'm going to go to like a Windows 10 virtual machine and set up all of this in Windows as well. And we'll talk a little bit about the C++ compilation process, the linking process. We're going to use a Makefile, and so I'll go over the Makefile and exactly what it means and how you can get all that up and running with Visual Studio Code. So here we go. Here's Visual Studio Code. I've already got that installed on this Linux system because, you know, that takes a few minutes. So you just download the deb. So this is X Ubuntu, so it's just an XFCE user interface for Ubuntu, so you can just get up, just install code right there. On Linux, there's one extra step. If we go over to the instructions, I have changed the instructions a little bit. Originally, they were using G++ as the C++ compiler. I've changed them to use Clang because I've been using both G++ and Clang lately, and I find Clang is actually a little bit faster. The programs that run a little bit faster, and also the error messages that you get when you're compiling are a little bit better in Clang, I find. So what you do is you would take this command here, you just copy it, you come over into your terminal, you paste that, let's see here, paste, and you run that command. So I type in my password, and it would install all those things. So you would just type yes, 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 and then all of those things would be installed, and you're all ready to get up and go. So I already have those installed because it would have taken a little while to do that. So VS Code is installed. I have run that, and now what you may want to do is you may want to restart your terminal. Okay, that may be a required step. So I'm just going to restart my terminal here. And then once you've got your assignment extracted, I've got a little folder here, COMP4303/A2. So I'm going to use A2 as an example for this one, just because it's a little more interesting visually, but everything is exactly the same for A1, okay? It will be the same for A1, A2, and A3. I was just testing out some stuff with A2 to see how it worked. So what we're going to do now, in order to use, well, we can ignore all of this stuff because we're going to go over a little bit of a different instruction here. VS Code is really nice because you can open a folder on your computer as a sort of workspace, okay? So if I type ls here and I look at this, this is the standard folder layout that I have for all of my assignments. So I have, let me do lsl. So I've got a bin folder, a source folder, a Visual Studio folder. You won't need to worry about the Visual Studio folder for this. Remember, there's a difference between VS Code and Visual Studio. Then there's a Makefile and the README file and the marks file. So what we're going to do here, in order to open up any directory as sort of a project in VS Code, you can just type code and then the folder name. So I'm just going to say code dot, and that will open up VS Code, and it will open up this folder over here on the left-hand side. So if you look over here, this is the A2 folder. It's got a bin directory, it's got a source directory, it's got the Visual Studio directory, here's the marks file, here's the make file, and here's the README file. Okay, so this is how you would open that here. So, for example, if we want to start editing, all we would need to do is click the source dropdown, and I would come into like my, this is the solution code, so I don't want to look into it too much, but let's just open our main.cpp program, and we can type and edit our code here like this, okay? So that's fine. This is like a glorified text editor at this point. We've opened up all the files, we've got a nice little way of viewing all the files in the folder, and we can open them up and they pop open in the text editor. So how do we go from there to using this as a sort of development environment? So that's the big step, right? So there's one thing that I want to do first. If we go over to the extensions part, then there's this C/C++ extension. So up here, if you type C/C++, you'll get this official Microsoft C/C++ extension, all right? And that, if you install that, that's going to enable essentially IntelliSense debugging. We're not going to get into debugging here because I haven't fully processed all the debugging features of VS Code yet. But you do want this for IntelliSense and code completion. Okay, so you can just install this and that should work right out of the box. The only additional thing you might have to do in other operating systems, it doesn't seem to need to be done for Linux, is in order to configure the C/C++ extension, you click this little gear and you go to extension settings. And in here, there is also a folder somewhere. We'll look at this when we get to Windows. But there will be an option here where you can specify additional include folders. Okay, so you don't need to do this on Linux because Linux is a bit smarter about knowing where the includes are. But on Windows, you'll need to specify a little folder here inside the options in order to be able to do the autocomplete stuff for SFML. Okay, so that's all you have to do is you just have to install that one little extension. Now, if you look at a tutorial on YouTube for how to use C++ and Visual Studio Code, they may install a bunch of different things. For example, there's this one popular thing called Code Runner. There's another thing called Make Tool or a Make Extensions and stuffing like that. We're not going to install any of that stuff. I'm just going to go bare bones with it. Okay, so I'll show you how I have set this up. And so, for example, let's just open main.cpp. So this is the main.cpp. You can see here, if I want to, for example, let's set up a new standard vector. Well, up here, I would include vector. And you can see it has full IntelliSense code integration like right out of the box. So I can say standard vector int myvec, right? And so we have all like syntax highlighting, error highlighting, all done. It's great. It's almost just like Visual Studio, but it's inside of VS Code. All right. So this code already works. I don't need to do much editing for here. Just like you would be given this assignment structure, for assignment 2, right, with the bin directory, source directory, Visual Studio directory, you are given that for assignment 2 as well as assignment 1. So how are we going to actually run this code and compile it? Well, that's where things may get a little bit complicated if you don't have a professor who provided all the things for you. So what we're going to do first is we're going to come up here to Terminal, and then we're going to click New Terminal. And then what you see, which is really nice about VS Code, is that you get a terminal right inside the IDE that is already open to the folder that you have open in A2, right? So if I type ls down here, it's the same thing as if I had a terminal open to there. Okay, now, if you want to build and run the program, and I'm going to show you the command and how it works first, and then I'll go explain it, all you would have to do is type make run. And this will build the program, and then it will run it. So here's assignment 2. Assignment 2, one command, make run, and you're up and running. Okay? I'm not going to get into what assignment 2 is doing. This is a bit of a sneak peek at assignment 2, but I just wanted to show you how easy that was, right? You type literally one command. Okay, so let's go over to the Makefile now, and I'll show you how all that magic works. So there's this program called Make, and Make is an excellent program. It allows you to compile programs very, very easily. Now, it has a bunch of other features that we're not getting into in this course, but essentially the main feature of Make is that you can specify like variable names and set up your compilation steps in really, really intuitive and easy to understand ways, and then you just type make and it will compile your whole program for you. If we go back into our instructions that we had before, you can see here that you could compile the entire system with a single command, right? Like you can type clang source/star.cpp include source standard equals C++11 output file library includes, but there's a lot of things going on inside that command that, you know, maybe they're a little bit confusing, or it's a really long command, or that command will literally recompile everything every time you run it. And a lot of that stuff you don't want to have to do, right? You don't want to have to remember a very long command. You don't want to have to recompile everything if you've only made a small change in one file. So this is where the Makefile comes in, and I'll show you how that Makefile works. So let me just quickly copy this command so I can put it over here in the Makefile so we can see what the Makefile is doing. Now there's a bunch of stuff in the Makefile and it's kind of scary, but just trust me, it's not going to be that bad, okay? So actually, I'm not even going to need this because I think you'll be able to follow along pretty well. So let's go through this line by line. And what we had before was this one command, clang. Okay, I want to compile all the source. I want to include the source directory. I want to set the standard. I want to do all this crazy stuff. Well, we're going to do all of that with these nice, neat variables inside the Makefile. So this is the Makefile, and I'm going to go through each of these variables so that you know exactly what the Makefile is doing. You don't necessarily need to know what the Makefile is doing in order to use it for the course, but you know, this is a bit of an extra tutorial, so why not? So this first one, these variables, these could be called anything, okay? These variables, don't have to have these exact names. However, these names are sort of traditionally used by programmers who use Makefiles, okay? They may look a little different in some people's projects and other people's projects, but these are just arbitrary names like a variable in a program, okay? So the first one is CC. And what CC is, that is the compiler that we're going to be using. And here in Linux, what I would recommend is that you use Clang++. So that is the Clang C++ compiler. So later on, we're going to be calling CC, and we're going to be using Clang++. If I wanted to switch the compiler that I'm using, all I would have to do is just change this to G++ instead of Clang++, and now the whole Makefile still works with G++ instead of Clang++. Okay? So Clang is the compiler. Here, I'm saying that I have a directory of source files, and they're all inside this directory called src, right? So inside src, which is local to the Makefile, I have all of my source files. Now again, this doesn't have to be called src_dir. I just wanted that name to be like that. Then I'm going to have the bin directory, and that's the name of the directory where I want the binary files or the executable files to go once I've produced them. This is the bin executable, that's what I'm calling this, and that is the output file that we actually want to generate, okay? So this is the bin executable, and here, this output, that is going to be the name of the file that we generate. Now, this command is a little bit, complex, but what I've done essentially is I've made a single Makefile that works under Windows or under Linux or Mac. So what this does is, if you're using Linux or Mac, then you would just call the output executable file SFML game. And then you'd type ./SFML game to run your game, okay? So here, what I've done is I have one extra step where I say, if my operating system is Windows NT, now Windows 10 is Windows NT when Makefile identifies it. So this here essentially says, if I'm running Windows, I actually want the file to be .exe at the end. Otherwise, it's just the normal exe file. Okay? So this is specifying the name of the file, and essentially all it says is if it's Linux or Mac, use what I already have here, but if it's Windows, put .exe at the end. All right? So this is where I'm setting up all of these things so I don't need to type them manually again later. Next, whenever you compile a C++ program, you're going to have for each .cpp file, you're going to have a .o file. That is an object file. And by default, if you just say compile everything, then the object files will be inside the same directory as the source files, and then it just gets really cluttered. So what we've specified over here is that there is going to be a directory where we put all of our temporary object files, and that is inside the bin directory in the obj folder. So if I go over here and look at the bin folder, I have an obj folder as well. So that's where all the object files are going to go. You can pretty much ignore them, but that's just where they go when they're compiled. Alrighty. Next, I have include directories variable. So this will tell us where am I looking for including headers from. Okay? There's two places in this project where we need to include source code from. One of them is here in the source directory, which is just the src folder. And so we say -i, which means include, and then we call the variable name source directory. The other place that we need to include from is the SFML directory, okay? Now, you don't need this command here if you're running Linux, because Linux knows where all your libraries are. They're in like user include or something like that. But this is here because this is necessary for Windows, okay? So in Windows, what this will do is it will look up that environment variable of SFML_dir, and it will include all of the things from that. Someone in the chat just said lib. No, it's not lib, it's include. Lib is different from include, okay? The lib_dirs, that is where the precompiled library files are that you need to link into your program. Those are located here at sfml_dir/lib. So wherever you set up that environment variable, and we'll go through all that for Windows, that is /lib, that's where your library files will live. Okay. Next, we are defining some variables which are going to hold essentially a list of all of our source files. So here we're going to say these are all of the source files. So this is all of my source directory /cpp files. Then I have all of my header files, which is the source directory /h files. Then I have my object files, and this is a little bit of a complicated thing, but in order to define my object files, I essentially do this like substitution string on the source files, and instead of .cpp, it's .o. Okay, so that's what that thing is doing. So now I know where my source files are, where my header files are, and where my object files are. Then I have my CPP compilation flags. So whenever I go to compile my program, here are the flags that I have for my compiler. And for now, I just have pretty simple flags, which are turn on optimization at its highest level and use the standard of C++ 17. Next, I have LD flags. That is the linker flags. And the linker flags essentially just say, what libraries do I need to link against? Okay, so I'm going to link against these SFML libraries wherever they may be. And lastly, I have one thing which is called make flags. And what this does is it says -J8 just means that whenever I run make, it will run 8 compilation processes in parallel. Okay, so it won't wait for each CPP file to be compiled. It will compile them all in parallel up to 8 at a time. So that's what that little thing does. If your computer doesn't have 8 processors, you can turn this to 4, or you can just completely remove this line if you want to. Okay, it doesn't really matter. -J8 is just going to make it run a little bit faster. Alrighty. So now is where we tell the Makefile how to actually build the program. Okay, I see some questions out there that are kind of unrelated to what I'm doing right now. I'll gladly come back to those later and answer all those questions, but I just want to kind of power through this tutorial first, and then I'll come back to those questions. So this here specifies how we are going to compile the object files from the source files and place them into their directory. So in a Makefile, if you have this sort of syntax, it essentially means, okay, I am going to produce inside the object directory a bunch of object files. Those files are going to be reliant on, and those come from the source directory CPP files. So this essentially says every single CPP file in our source directory is going to produce an object file in our object directory. All right? And if it comes after the colon, this also means that if either of these things have changed, then we are going to recompile. This is the really cool thing about a Makefile, is that if nothing has changed in any of your source files since you last typed make, it won't do anything. So I'm going to come down here, I'm going to type make, and see it says bin/SFML game is up to date. That means that I haven't changed anything. But if I come in here and I say put a space in main.hpp or main.cpp and I type make again, then all it does is it recompiles the main.cpp file. It doesn't recompile any of the other CPP files. And then, because it had to recompile one of the object files, then it does the linker step again. See how that works? So, it's really nice because you save a lot of compilation time, especially for very, very large projects. For our assignments, it may not save that much time because we only have a few CPP files, but, you know, it's nice to only recompile what we need to recompile. So the second line here defines the command that needs to, run in the terminal in order for this to actually be executed. So this says run cc, which is Clang++, for all the CPP files, and include all of the include directories. -C means generate object files, and the output files should be named @, which just means take the name from up here. Okay, so this runs the command to compile all of the CPP files which have changed, generate their object files, and put them into the object directory. Perfect. The next one is the actual linker step. So that was the compile step. Now this one says, okay, my output, which is up here, which is either bin/SFML game, or if it's Windows, it has a .exe at the end. The generating of the final output executable is dependent on the object files and the Makefile, right? Because if I change the Makefile, I want to recompile things. So what that does is it runs CC, it includes all the libdirs, the linker flags, and the object files, and it says -o generate the final object. Okay? And then there's one more thing that I want to talk about real quick, and that is that this is the all flag. So whenever you type make, you can specify an additional command, right? And I'll talk about those commands in a second. But if you don't type anything, by default, it runs all. So whatever we put here after this colon, it's going to generate. So what happens is the following. If I type, well, let me type make clean. Make clean is going to remove all my object files. So if I just type make, it's going to try and do all. All tries to do output. Output is dependent on the object files. Object files are the ones that are up here. So it's going to run the compilation step, then it's going to run output. And if there was anything else down here to do, then it would do that. Okay? And the last thing I have in this file is a couple of additional things that just make your life a little bit easier. One is called run, and one is called clean. So what run does is if I type make run, it will do all the building, and then it will cd into the bin directory, run the program, and cd back out of the directory. So this says, if it's Windows, here's the command to run under Windows. Otherwise, if it's Mac or Linux, here's the command to run under Linux. So if I type make run, what will happen is, well, this depends on output. So if the program hasn't been built yet, it will do the building. So let's just run make and we'll build first. Okay, so it will build everything, but it didn't run it because all, by default, it just runs this, right? So now if I type make run, well, everything else is done for us, so it runs this command, which is the Linux version of this. So it does cd bin, it goes into the bin directory, it runs the SFML game command, and when SFML game is finished, it will cd back out of that directory. All right, so here I'm going to go back over here, I'm going to exit, and it will come out of that, and I'm back. All right, and the last one is make clean, and what make clean does is it removes all of the object files and the executable file. So what that does here in Windows, it uses the delete command. So it says delete all of the object files and delete sfmlgame.exe. And if I'm not in Windows, I'm going to use rm. So remove the object directories, object files, and remove the output file. Okay, so down here, I can type make clean, and you can see the command that gets run. It goes rm bin obj star.o, that's all the object files, and rm bin /sfmlgame. Okay, so you've got three things you can do with the Makefile, which is really, really convenient. If you want, you can just type make run, okay? That will compile and run the program. If you're super lazy and you don't want to type run, then what you can do is you can come up here to the all command, and you can put run inside all. So then what all does is it will do the compilation step, and then it will do the running step as well. So let me make clean to undo all of my compilation, and then I will make again. And so make will do make, and then it will actually run as well. Or it didn't. Crap. Why didn't it do that? Did I save? Let me try it once more. I'm not sure why that didn't work, but we'll leave it out for now. And let's see here. We'll just type make run when we want to run the program. Alrighty. So that is how you compile the program. That is how you run the program. And that's what you'll do for your assignments. However, sometimes it's a little bit annoying to actually have to come down here and type make. Even though that's super convenient, you know, that is like 10 keystrokes. It's a little bit of mouse movement. Let's see if we can get this done any faster, okay? So what we're going to do in Visual Studio Code, in VS Code, we're going to go up here to run or terminal. Where do I go? Okay, so up in terminal, we're going to click terminal, and then we're going to click run build task. So we'll click that. And then by default, it says that no build task was found. So we haven't configured what actually builds our program from within Visual Studio Code. So far, up until now, all we've been doing is typing this make command, and the make command is sort of this command line thing, right? It has nothing to do with Visual Studio, or sorry, VS Code. So VS Code is now saying, okay, I don't know what the build task is, so let's set up the build task. So I'm going to click here, and it says create tasks.json file from template. So that's what I'm going to do. And then I'm going to click others. All right. So others. Perfect. So what happens now is we get this tasks.json file. And this is where we can define some tasks that we can set up to be run, and we can set up hotkeys for those tasks within VS Code. So here it sets up this sort of default thing. I don't want to echo. So I'm going to call this 4303 make. Okay, that can literally be whatever you want. That's just the label that shows up. Here, this is a type shell, which means it's going to run in the shell. And down here, I'm going to type make run. And that's the command that's going to run in the terminal when I invoke this task. So now I'm going to come up here. I'm going to close this out now that I've edited that. I'm going to come back to main.cpp, and I'm going to say terminal run build task. And now it's going to say select the build task to run. And I should be able to say 4303 make. No, why can't I do that? All right. I just defined one. Okay. 4303 make. Why isn't this working? Okay, so if I go up here and I click run build task, okay, now it worked for some reason. There was just a weird bug with the key shortcut. So now when I click build task, it says no build task to be found, configure build task. And now that thing I just set up here, 4303 make, I don't think I saved the file. I can click that, and then that inserts some text in here. Basically what it does is it says this is now the default build task for Visual Studio Code. And so with just a few clicks, what we can do is now whenever I go to run build task, it knows that the default build task is to go to the terminal and run make run. Okay, so let me just make clean down here. So nothing is compiled right now. Now when I go to terminal, I can say run build task, and it does make run down in the terminal for me, and it builds and runs the program, which is really cool. Because now what I can do, this is what I do, and I really like this, is I can go Control-Shift-P, and then I can say open keyboard shortcuts, or let me go over here. I'm going to go to Preferences, Keyboard Shortcuts, and down here, I'm going to go to Build, and run build task. So by default, run build task has Control-Shift-B as its keybind. But what I do is I like to have that be just Control-B, because it's like Control-B isn't used for anything else for me. It says, oops, one existing command has this keybind. So now I'll click here. All right, so I've already got something. So run build task, now I've got that bound to Control-B for build. And now whenever I'm editing code, all I have to do is hit Control-B and I compile and run my program. Okay, and it gets run down here. I can see the output. Whenever I close, it stops. So it runs that in the terminal down there. It's super, super convenient. So that's basically it, is that you can use Visual Studio Code or VS Code in this really cool way where like, okay, here's my, like, I've got my profiler code, I can edit this, and now I want to run it. So let's say I make a slight change to this file, I hit Control-B, now it compiles and runs it. Well, let me make a change to my Makefile, it compiles and runs it down there. So it recompiled, then it reran the program. Done. And so that is how I will suggest that if you are using Linux or Mac in this course, that you should set up to use your assignments, okay? You've got a really nice Makefile that's kind of self-explanatory once you know the syntax of a Makefile. If you really want, you can just open a new terminal and you can type make or make clean to remove it and make run. You can do all that typing down in that terminal if you want to. Or you can set up the default build task like I have here. You can actually just pause the video here and type this into your tasks and it will work. You don't need to go through those menus. And I think that what I'm going to do is I'm going to re-upload assignment 1 with the VS Code folder so you will actually have this here. Okay? All right. So that's really, like, I spent 90% of that time just explaining how to do the Makefile. Right? So, or what the syntax of the Makefile was. The actual setting up of VS Code was pretty trivial, in my opinion. And now you've got like a one-click solution to save, compile, and run your program really easily in Linux. All right. Now, let's switch over to Windows. So, if you are completely, perfectly happy, oh my God, look how blue I am from this. This is hilarious. If you are completely happy with assignment 1, if you already have it set up and it's already working, you can just completely work with Visual Studio if you want to. That's fine. There is nothing wrong with Visual Studio. It's a great piece of software. However, what I'm going to do is I'm going to show you how you can do what we just did, but now we're going to do it in Windows instead. Okay? So these instructions aren't written down anywhere yet, but I'm just going to take you through them. And I haven't practiced this on my virtual machine yet, so this may end in disaster, but we'll be in disaster together. Okay, so let's first let's look for Clang. So I'm just going to Google Clang, and Clang C language. All right, so this is Clang. I'm going to go here, and I'm going to go to download. And I haven't set up any of this up yet. So 13.0, okay. Sources, pre-built binaries, Doxygen. These are available on the GitHub release page. Let's go here. And we will go down to, hopefully there is Windows. Let's see. Maybe I should have looked at this beforehand. Maybe I'm not looking in the right place. Oops. This is the documentation. Where are we? All right. I'm obviously doing this live. Okay, here we go. LLVM 13.0 Win64. So we're going to be using the 64-bit version of that. So sorry for that little hiccup. So we're going to download this. We are going to save it. We are going to save that to COMP4303, my folder. All right. And the next thing we're going to install is Make, because we need the program Make. So GNU Make Windows. So Make for Windows, GNU Win 32. Complete package setup. So let's download this. This will start downloading in a second from SourceForge. So all we have to install is Clang and Make. Not too bad. Alrighty. Come on, you can download. Why is this blocking? Oh, SourceForge. Did that already download? Nope. Where is it? My download will start shortly. There it is. All right. So it did start shortly, but not shortly enough. So there's Make. Okay. So we've downloaded Make and we've downloaded Clang. So that part is done. And I've already installed Visual Studio Code. You know how to install VS Code on Windows. It's super easy. So we'll go into the COMP4303 folder and we will first install LLVM. So LLVM is what installs the Clang compiler for us. So we'll do that first. Yes, I want to run this. It's going to take a minute. Has there been someone recap me on what's been going out in the chat so I can answer any questions, because I haven't been really paying attention up until this point. So a lot of talk about linear algebra, about math. That's pretty neat. Someone called the stream a disaster. I wouldn't go that far. Someone wants to know what math is required for comp sci. I would say the things that are going to help you most, I don't want to say the word required. The things that will help you most are some sort of discrete math, or linear algebra is really good, that sort of thing. Like your basic intro math courses. You don't need to know a lot of math to do computer science. All right, so LLVM has been extracted. Now we're going to install it. So we go to Next. I agree. I am going to add the LLVM to the system path for all users. So what that does is it adds it to our path environment variable. So whenever we type Clang, we can type Clang from anywhere and our system will know what that is. We click Next. And I'm going to install Clang in my C drive, libraries. Okay, so C libraries LLVM, because I want all my programming stuff in my libraries folder. So C libraries LLVM, install. That's going to install for me. Perfect. So that's done. Next, I'm going to install Make. Next, I accept the agreement. Next, I'm going to do the same thing with Make. I'm going to put that inside libraries. So I will have GNU Win32 inside my libraries folder. Install. Perfect. All right. Now, because I installed, if I go over here to my libraries folder, so C libraries, GNU Win32, I have a bin folder here where the make command is. I'm going to have to add this to my path, I believe. So if I go over to my environment variables, I'm going to set that up. So edit environment variables. If I come down here to path and click edit, then I'm just going to put in my bin folder for make so that my terminal will know where make is on my system. And if I come down here to the path, then it should, yeah, so libraries LLVM bin and GNU Win32 bin, that's the extra step that you have to do in Windows, is actually add them to your path so your computer knows where they are. All right, so now I have those two things installed. The next thing I want to do is, if you're using Clang, you may as well use the 64-bit version of SFML. Why not? So what we're going to do is we're going to go download SFML again, but we're going to download the 64-bit version of SFML this time. So we'll come over here, download it, and we will download the 64-bit version of SFML. You can use the 32-bit version, that's fine. But I mean, we're using a 64-bit compiler, so why not use the 64-bit version? So I'm going to put this over in C libraries. So I'll put that there. Then I'll come back here. I'll go back to C libraries. And when this is finished downloading, I should have my zip file. Almost done. Pretty slow for some reason today. Let's go. All right, perfect. So here is where I previously had SFML installed. I'm going to rename this to -32. That way I know that that is the 32-bit version of SFML in that folder. Now I'm going to extract this version of SFML, and I know that this one is the 64-bit version of SFML. So I'm going to call this -64. Okay? So I'm going to come in here and remember how we had to set that SFML dir environment variable last time? Well, on this machine, I had that set to the 32-bit version, which no longer exists. So I'll go back to my environment variables. I'll click here. I'll go to my SFML dir, and I'll change that to be the 64-bit version. All right. Perfect. Now we're done. All the setup is done. All I need to do now is if I go into Visual Studio Code, so I'm going to open up Visual Studio Code, and I'm going to go to File. Oh, this is a previous assignment from another course that I have open here. Don't save. Nope. Nope. Don't save. All right. File, we are going to open a folder. And I'm going to open inside Desktop 4303. I have assignment 2 here. So this is the same thing we just had in Linux, but now I have it open in Windows. Okay. So if you see, all the files will be the same. Yes, I trust the authors. I'm not going to do anything scummy with you. So over here, we have all of those same things. We have the same Makefile. We have the same source code. We have the same, you've just extracted your assignment folder here, basically. So down here, it says, do you want to install the recommended extensions for C++? Yes, let's install that. So that wasn't installed by default, but VS Code is pretty good, and it just installed it for us. All right. So I'm going to close that now, and I'm going to come back over here, and what I'm going to do is exactly what I did before. So I'm going to open up a new terminal. That should open up at the bottom. And if I did everything right, if I set up Clang properly, and if I set up Make properly, and I added them to my path properly, then I should be able to type Make here, fingers crossed. Oh, I got to make clean because I was already in here and did this before. So Make, boom. It's compiling. There we go. It has compiled everything using Clang. Look at that. Now I can type make run, and it runs. Okay? So the setup is super easy in both operating systems. The Makefile, I took great care in making the Makefile work for both Linux, Mac, and Windows. So it should work for all of them. So literally all you have to do, again, is if you're starting from fresh, right? So let me clear this out. So let's pretend we haven't compiled anything. You can just type make run. It will compile and run the program. Now, the last thing I'll do is in Windows, I'll show you again this step where I go terminal, run build task. Oh, I see. So that's funny. I copied over the tasks.json, and the tasks.json already had that in there. So if I hit Control B, no. Okay, so the last thing I need to do is I need to go to my preferences, to my keyboard shortcuts, and I will type in CTRL plus B, and that'll show me what is currently Control B. So toggles sidebar visibility. I don't care about that. Let's remove that key binding. So run build task. I'm going to double click that, hit Control B, hit enter. Now I'm done with my keyboard shortcuts. And when I go back over to like my main.cpp, if I hit Control B, I'm going to do make run, and it'll run my program for me. So it's actually like pretty cool and pretty convenient and doesn't take long to set up at all, right? So that's in Windows as well. So Windows, Linux, and Mac, now we have the same development environment and the same instructions for everybody. The only difference is, like in Linux and Mac, it's like a single command on the terminal to install everything, versus in Windows, it's a little bit more annoying. You have to go out and download and install stuff. But I think what I'm going to do in future versions of the course is sort of recommend this way, maybe even for 4300, because I think it's nice to have, like, if you're working with a partner, now you can actually be working with a partner. Like if you're using Windows and they're using a Mac, it's all the same, right? You can share all those files and it's all good. All right. The last thing that you will have to do over here is inside Windows, if you want auto-completion of code to work with SFML. So for example, down here, I can say SF render window. Does that work here? Maybe it doesn't yet. Just give me a sec. Because over here in the C++ properties.json, in order for it to see all of the SFML code to enable IntelliSense and autocomplete, Oh, I think it's still setting something up down here, so that may be why it didn't work. The only thing you have to do is inside your C++ properties settings.json file, you have to add your SFML include directory to your include path so that Visual Studio, for the purposes of IntelliSense, knows where to look. Okay, so here, what you do is you just use this syntax with a $ and some curly braces, and you type env : SFML_dir. That tells Windows, okay, this is your SFML_dir environment variable that you set up, and it's inside the include directory there. And then everything should work as normal. So if I say like g dot, yeah, I trust me that it works, but I think right now my VS Code is actually busy installing something, so IntelliSense may not be working. But that's it. I thought that was really neat. I spent a bunch of my weekend like trying to investigate that, how like, you know, Windows people in the course kind of have an advantage in the fact that they use Visual Studio, which is really nice. But I think now everybody can use VS Code if they want to. And turns out for assignment 2, if you're using a 64-bit compiler, your code is going to run a little bit faster, right? So you may, like our projects for Visual Studio are actually set up to be 32-bit compiled. 64-bit compiled is actually going to be a little bit faster, and we'll get into all that when I talk about assignment 2, and hopefully you'll have a tough time writing code that's as fast as mine because I spent a lot of time optimizing it. But I hope in assignment 2 you actually beat my time because I want to be better. So whenever someone is programming with you in like a competition, you want to be beaten because if you win, you have learned nothing. But if you lose, you can talk to them and see what they did, right? So it was really funny. In the first year that I offered this course, nobody beat me. In the second year, which was last year, one of the students actually did have code that ran faster than mine. And I was like, holy crap, how did you do that? And I learned something really, really interesting. So I'm going to go over my code and how I got it so fast once everyone has handed it in. But that should be pretty fun. And I think using Clang as the 64-bit compiler is how you're going to create your fastest code. Someone just asked, what did I learn from the student? I will tell you what I learned after the assignment has been introduced, because it will make no sense to most of the students if I talk about it now versus if I talk about it then. So we'll leave that for assignment 2. But yeah, unfortunately, I would have loved to show you a Mac virtual machine, but I have not yet figured out how to get a Mac virtual machine up and running in Windows. I would have to go down the rabbit hole of some Russian torrent sites in order to get an ISO that works properly, and I'm just not willing to do that right now. But it should be very, very close to the Linux setup. So that's that. All right, so that took about, 50 minutes with a lot of explanation. And you can see just how easy this is to set up. And I really like it, and I think I'm going to start maybe using it for the courses rather than Visual Studio because it's just so much. It's so nice as a professor to have everyone using the same piece of software. Rather, like, for example, I know someone the other day messaged me on Discord and said they were trying to set up the assignment in Xcode under a Mac. And I have no idea what Xcode is, what the options are, anything like that. So now hopefully that student, instead of using Xcode, could use Visual Studio Code and just like be using the same thing as everyone else, right? Okie doke. Well, that's it. This was sort of a bonus lecture. I don't want to stay lecturing for too long. I've got to save some of my voice for tomorrow. So thank you all for tuning in. This is going to be a special link on the spreadsheet called VS Code /C++/Makefile tutorial or something like that, down with the important links section. So that's where you can find this lecture on YouTube as soon as I upload it in a few minutes. Great. I will see you in the next lecture.